To understand what a function is, we have to compare it to something we already know, the script. Both scripts and functions contain a series of MATLAB statements or commands which are stored in a MATLAB file. The script is static, that is, that it cannot take input and return output. However, the function can take input to return output. So it is more flexible as we can give it new input to work with instead of having to open it and change the code inside each time. Let's look at an example to understand this better. Here we have a MATLAB script which sums up the numbers x and y equal to 15 and 5 to display 20 at the end. If we wanted it to sum to two different numbers, we would have to open up the script file and change x and y's values. Using functions, this can be avoided. Here we simply provide the values of x and y when we call the function. They are the function's input. Before we will try these out in MATLAB, there are some important rules to keep in mind. First of all, the function name must equal the name of the file the function is stored in. Secondly, the function ends with an end statement. Thirdly, the function does not have to have any outputs or inputs. Next up, we will look at variables that are used in the function. These do not appear in the workspace and so are only accessible within the function. They are local variables and need to be declared global if you want to use them outside the function. There are some more rules, but that is enough for the beginning. Let's go to MATLAB now and learn to create a function. Okay, so here we are in MATLAB. Let's create a script and call it fun. Notice the little MATLAB symbol down here, which means that this is still a script. To make it into a function, we have to add function in the beginning and after it the function name, which must be equal to the file name, so in this case, fun. Notice how the symbol down here changes to the function sign. We will have no inputs or outputs for now in this function, just a variable c with a numeric value. Now let's execute it and see what happens. MATLAB just displays c and its value since we have not suppressed it with a semicolon, but other than that it doesn't display anything. C is not even over here in my workspace since, as mentioned, variables in a function are local. If we declare it global in the function and in the command window, however, it will be accessible. Now let's add some inputs, input 1 and input 2, by adding them after the function name between two parentheses. These inputs will be reassigned to the variables a and b inside my function. Now we can carry out a simple calculation and let the result be equal to d, and also display d to see the result. Sometimes you may want to do more than simply display the result. For example, what if I want to work with the result, maybe to use it in another function? I want it to be accessible in the workspace, so how do I go about making it accessible? I could declare d as a global variable, but if it can be avoided, one should not use global variables. But wasn't there something about functions being able to return an output? Yes, there was. We can simply make the function return our result and then we can access it from the workspace for future use. So let's declare an output called whatever you want, in our case output 1. Simply do this by writing it before the function name followed by an equal sign. Now let's replace d with output 1 and run this in a command window below. The output that the function returns will be stored in a variable of your choice. In our case, we will call it var. If you do not assign a name, it will be stored in ans, as we already know from the previous variable video. Now we can manipulate the function's output however we want. We can even have more than one output by simply creating an array of outputs, such as so. Now we can store a second output in output 2. Let's use our new knowledge for the previously created cookbook function. Up to now, we always had to change the medium and volume value if we wanted to make a different medium or amount. That meant having to open the script each time. Let's convert it to a function with two inputs that are simply the medium and the volume, so that we can specify both when calling the function. First, we declare it a function using the function keyword, followed by its name and the two inputs in parentheses. We can delete the two variables down here as they are now specified in the input field. Now all that is left to do is add the end command at the end and check if it works. Now let's make 444 millilitres of LB agar. Here we can see that this has worked. Super. However, I don't really like the way the output is displayed, and since we have a couple of minutes left, let's change this bit. First, let's surround the output by borders using the display function with a string of asterisks. This serves to separate the output from previous commands shown in the command window. Now I also want to state the volume and medium in a sentence, not just as two values. I cannot use the display command for that, seeing as I need to convert my variables to a string. We will use the fprintf command, which does that for us. In it we will have our string with the percentage sign as an indicator that the variable's value will be filled in here. The variables will be listed in the end in the order that you want them to be displayed. Now we also need to specify some more details after the percentage sign, namely what the variable gets converted to. In our case, I want the volume to simply be displayed as an integer, so a simple D is enough. The medium I want is a string of characters, so an S is required. In the end, I will also have to put a new line character symbolized by \n, otherwise we would print our next line on the same line as this one. To learn more about these conversion types, look up the documentation for fprintf or for sprintf. Now let's check if the output looks a bit nicer, and indeed it does. Thank you for watching. This has been the iGEM Academy MATLAB video series. This video was on scripts and functions, and our next video in this series will be on loops.